Students, this is the most tricky part of this whole question, that you have to prove that the sun stays in a main sequence belt of the, if you remember the graph, HR graph, for how many years? 8 multiplied by 10 raised to power 9 years. Okay. Now, how can we prove it? Okay. We must develop some logical method which would give us the end result, this value which we need to prove in this question. Okay. So first of all, let's see what information is given to us. So they say categorically that the total energy that is released in a one reaction is 4.3 times negative 12 joule in a one complete fusion reaction. Okay, the three-stage reaction. And during the whole lifetime of sun in the main sequence, okay, when it is a normal size star, okay, when it has not become the giant star, okay, the red giant star, understand, is that the sun, the 10% of the total mass of sun is consumed. Okay, consumed means that that converts into the energy. Okay, and that energy is radiated in the whole lifetime, 8 multiplied by 10 to the power 9 years in the main sequence. Again, it's not a complete lifetime, but just for the main sequence. So let us quickly find out that what is this total mass, by the way. We can say it is zero point 0.1 times 1.5 times 10 power, or okay, here notice that when it entered into the main sequence, then its mass was 1.5 times 10 power 30 kilogram. Okay, so you don't need to use this value, you have to use this value when it entered in the main sequence, right? But when it will leave the main sequence, dear students, then its mass will be 1.5 times 10 power 29 kilogram. Okay, so this is an important value because this mass is consumed to completely to produce the fusion reaction. Okay, now let's develop a logic of finding out the time. Okay, now dear students, if you understand this method, it will really help you. First of all, this information is also given to us in this question, that this is a luminosity. Okay, and you know the luminosity means that is actually the power, right? The power of the sun. It tells us that how much energy is radiated per unit time. Okay, so don't you think that it is basically, if I generally write, or if I write the luminosity is equals to the energy released. Okay, so I will tell you very easy and logical method. Okay, it will eradicate all the confusion. So this power is equals to 3.8 times 10 power 26 joules in 1 second, right? So how much mass is consumed in 1 second, which is producing 3.8 times 10 power 26 joules? If you can know that mass, okay, then you can also know that mass which is completely used in this amount of time. And we know this mass already, that 1.5 times 10 power 29 kg is used in fusion reaction in how much time? In 8 multiplied by 10 power 9 years. Okay, all right. So don't you think now we can make a method? I mean, if I take a time on the other side, okay, so then I can say the energy released luminosity. Okay, so what if I say this is our the whole lifetime of a sun in a main sequence, right? So if I say the total time, just make a equation logically. So then this total time, dear students, will be equals to the total energy released. Okay, not in one reaction, in the whole lifetime in a main sequence, total energy released divided by, and we are supposing, dear students, here that the luminosity is constant. Okay, so this is now our main equation. Ultimately, we will put the values in this equation, right? So now let's see the logical flow. Okay, if you want to know the total lifetime, you need to find out the total energy released. Okay, okay, point number one. Point number two, if you want to know total energy released, you need to know how many reactions that were carried out during this 8 multiplied by 10 power 9 years. Okay, so number of reactions. Now if you want to know number of reactions, you need to know how much mass was utilized, was exhausted in a one reaction. Okay, because we know the energy released in one reaction, and we know that how much total mass is utilized in throughout the time. But how much mass is utilized in a one reaction, that will be 4 times the mass of proton, means the 4 protons were utilized. So mass used in a one reaction, don't you think is the total mass is 4 times the mass of one proton, right? So mass of one proton. So which is, dear students, is the 4 times 1.67 times 10 to the power negative 27 kilogram. This mass produced, okay, because this mass produced this much energy, okay. So it is 6.68 multiplied by 10 to the power negative 27 kilograms, okay. Now if this mass is utilized, right, we can find in one reaction, if you want to know the total number of reactions, so the total number of reactions we can find out by dividing this quantity, the total mass consumed divided by the mass consumed in a one reaction. You will get the total amount of reactions that were carried out. The energy carried out in a one reaction, then you can find the total energy produced. Then we will plug the value here and we can find the total time. So this is a flow. I hope you understand. So step 2 is about the number of reactions. Okay, that should be equals to the total mass consumed. Once again, I hope you understand, as for 29 divided by 6.68 multiplied by 10 to the power 27 kilogram per reaction. Okay, so well, the answer is, if I round it off, so it will be 2.25 multiplied by 10 raised to the power 55 reactions carried out, okay, in 8 multiplied by 10 to the power 9 years, okay. So if one reaction is producing 4.3 times 10 to the power negative 12, what is the total energy released? That would be our step number 3, okay. So yes, total energy released must be equals to the n multiplied by 4.3 times 10 to the power negative 12 joules in one reaction. Okay. So you can find in this way the total energy released. So the answer is 9 point, which I calculated, it's 9.68 multiplied by 10 to the power 43 joules, right? This is a total energy release. So coming back to the equation 1, right? So if you want to find the total time, so why not we put this value 9.68 multiplied by 10 to the power 43 joule over luminosity. Look at the luminosity value. It's 3.8 multiplied by 10 to the power 26 joule per second. Okay, so you see that joule and joule will cancel out. Second will go in numerator. So you will get the answer in terms of seconds, which you can then further convert into years. So the answer is 2.54 multiplied by 10 raised to the power 17 seconds. Okay, so we should convert it into the years, right? To divide this answer with 365 days. In one day we have 24 hours. In 1 hour we have 3600 seconds. So by doing this, you will get answer in years. So dear students, the answer is approximately, if I convert it into the scientific notation, then it is 8.05 times 10 raised to the power 9 years. Okay, which would be considered correct. And I hope you understand this tricky question. Yeah, take care.